Good morning, boys and girls, and welcome to the last day of this unit. Okay, today we're going to add all of the remaining power properties to our arsenal of mathematical abilities. Okay, we're going to start today with the power of a power property. If I have a base and an exponent, raised to an exponent. All right, so when you have a power of a power, that is telling you that, hey, those exponents, the base again always stays the same, but those exponents you can multiply together. If I've got 2 to the third raised to the second power, this is 2 to the third, and I can just multiply those exponents, and 3 times 2 is 2 to the 6th, and the base stays the same. Again, if you were in doubt, you could write all this out and see what it really means, and you would see that you would get 6 2's all multiplied together, or that is 2 to the 6th. Okay. As we talked yesterday, again, just be very careful if you're dealing with a base, an exponent, or coefficient, because again, the rules for all those things are different. Okay, so really think about what you're playing around with. All right. X to the fourth raised to the third power. And if I wanted to show work, power of a power, I'm going to multiply. So 4 times 3 is x to the 12th. Each of these rules by themselves, I think, are relatively simple. It's when we start mixing all the rules together is when things get complicated. Y to the third to the 5x. Power of a power, I'm going to multiply. It doesn't matter if it's got an x in there or not. Doesn't matter. 3 times 5x is 15x. So power of a power, just go ahead and multiply those things together. All right, so that's our power of a power product. Power of a power property. All right, next, let's move on to our power of a product property. Okay, our power of a product property is if we have a product like a times b raised to a power. All right, what you're going to do is you're going to raise both things or everything that's inside, that's part of that base. You're going to raise it to that power. So a to the m, and I'm going to raise b to the m. You guys kind of think of this like distributing. However, it's not technically distributing because distributing is over adding or subtracting problems, but it's kind of has the same flavor to it. Okay, I need to raise everything inside of that power. This is a great one to show work on. Like when I normally do problems, this is a step I normally would write out. I need to take a to the third, and I'm going to raise it to the second power, and I'm going to take b squared, and I'm going to raise it to the second power. Everything that's inside, you've got to raise it to the exponent. Now I can do power of a power. When I take a power of a power, exponent on an exponent, I multiply, and I get a to the 6th, and b to the 4th. Okay? Notice again, as we kind of do stuff, we might start not showing some work, but whenever you can, I think it's a good idea so we can see what you are thinking. All right? On 5, again, we got to be careful here as things get a little more intense, a little bit trickier. We're raising everything to the 8th power. And I say we got to be careful here because oftentimes, again, you don't view that negative as a coefficient. But again, that's really a coefficient of -1. So when I start raising everything inside to the 8th power, I've got to raise everything, including that coefficient of -1 to the 8th. M to the 7th, I need to raise that to the 8th. And n, I need to raise n to the 8th power. But this is why it's good to, again, write this out. I think if you write it out, you'll see what's happening a little bit easier. And you're less likely to make mistakes, especially this power of a product property. Write it out, write it out, write it out. Now, -1 to the 8th power. We talked yesterday about a negative number to an even power is always going to be positive. So that would become +1. Power of a power, I'm going to multiply. 7 times 8 is 56. And then this, again, really had a power of 1. 8 times 1 is 8, or this just becomes n to the 8th. So 1m to the 56, n to the 8th, or just m to the 56, n to the 8th. All right. Next problem now. Starting to mix our stuff together a little bit here. All right. 3y to the 6th squared times negative x to the 5th y squared z all raised to the 3rd power. When you start getting into more complicated problems like this, keep in mind order of operations, okay? Please excuse my dear Aunt Shanae. Okay, that's the way I always learned it. Please excuse my dear Aunt Shanae. Or PEMDAS. Some people use PEMDAS. The P stands for parentheses. So I've got to do inside the parentheses first, and there's really nothing to do. Then I'm going to move on to exponents. So those are like the 2 and the 3 on the outside. I want to raise those things to an exponent. So that's what I'm going to do first. I'm going to raise 3 to the second power, and I'm going to raise y to the 6th, the second power. That is my first thing that I'm dealing with. Then I got to raise all this other stuff over here, and sometimes it helps to use some other inclusion symbols, like I'm using brackets here. Now I need to raise all this stuff to the third power. So negative 1 to the third. Again, don't forget, that's not a negative x. There's no such thing as a negative x or a negative m or a negative variable. It's always the negative 1 coefficient that's in front. So I need to raise that negative 1 to the third power. I need to raise x to the 5th to the third power, y squared to the third power, and z to the third power. All right? Now, as I'm saying, write that property out. It'll help you in the long run. If you try to do 2 or 3 of these rules at a time in your head, you're going to get lost. You're going to get in trouble. Okay? Now, once that's written out, though, we can see you know how to use that property if we're grading you. And you can now focus on doing the property correctly. 3 squared is 9. Y to the 6th squared is y to the 12th. Negative 1 to the third, that's to an odd power, so it's still negative 1. Multiplier power of a power, x to the 15th. 3 times 5 is 15. Y to the 6th, and then z to the third. Now, I need to now multiply these together, so this goes back to our rule from yesterday. Okay? When you multiply monomials, again, you are going to start with leading coefficients. That's not attached to the y, and that's not attached to the x. Okay? So 9 times negative 1 is just negative 9. And then I'm going to grab my variables in alphabetical order. So x's come first, x to the 15th. There's just the x's. Now I got a y to the 12th and a y to the 6th. And again, so going back to yesterday's rule, when you multiply bases, you are going to add exponents. Okay? So 12 plus 6 is 18. And then I'm going to grab my z's, and there's only one z's. And that's what I'm saying. Like, this is not too hard. Each property by itself is not difficult. But when you start having to deal with multiple properties on multiple things like bases and coefficients and exponents, you really need to think about what you're doing. Okay? So be careful. Number 7. Next one now is kind of a trick question. I got negative y to the 4th. And I say it's kind of a trick question because usually you guys try this one on your own. And you try to raise everything to the 4th power, including the negative 1 in front. But in the case, again, that 4 is only on the y. The base is just a y. That negative 1 is not part of the base, so do not raise it to the 4th power. Like these last problems, the negative has to be inside the parentheses if you are going to, raise it to a power. So in this case, there's really nothing for me to do. This would just be negative. I've already raised y to the 4th, so negative y to the 4th, and that's my answer. All right, here. Moving on to the next one. Okay, next is our quotient of a power property. For a quotient of a power, again, if you have the same bases and you're dividing them, what you can do is you can go ahead and you can subtract exponents. When I multiply bases, I add exponents. So when I divide bases, I'm going to subtract exponents. So if I have y to the 4th over y, bases are the same. Again, this really has an exponent of 1. We just never put it, but you could always write it there if you want to. And so I would do y, base stays the same always, 4 minus 1. Or this is y to the third. Okay. Next one, same thing if the base is a number, okay, instead of a variable. The base always stays the same. In this case, my base would stay 7, and I'm going to subtract the exponents. Top minus the bottom, 9 minus 5, and this gives me 7 to the 4th. We don't say it here, but we are going to leave that one in exponential form, and we're not going to multiply out. All right? And then, so number 10, as my fractions get bigger and crazier, here's what we're going to do. Okay? Again, deal with each piece separately. Okay? And use the correct rules. So I'm going to start with just my coefficients. And I'm just going to look at the negative 3 over 9 part. And if I'm dealing with just the negative 3 over 9, hey, that's just a fraction, and I can reduce that. Negative 3 over 9 reduced is negative 1/3. So I'm just going to reduce the coefficients like normal, just like a regular fraction. I'm not going to go and subtract those because they're not exponents. This rule we just talked about here was an exponent rule, not a coefficient rule. So again, be careful what you're dealing with. W to the 6th over W to the 5th. I'm going to subtract those exponents. 6 minus 5 is 1. Because there's more w's on top, you're going to put that w on top. Or because the answer was positive. There's kind of different ways you can think about this. Because my answer was positive, I'm going to put the w on top. On the next one here, 4 minus 6. If I do 4 minus 6, if I always do top minus the bottom, 4 minus 6 is negative 2. So the fact that it's negative, and there's a power we're going to talk about down below, but the fact that it's negative tells me to put it on the bottom. And when I put it on the bottom, though, I put a positive number. Or because there's more x's on the bottom, when I do 6 minus 4, the answer's got to go on the bottom. All right? This might make a little more sense. We're kind of starting to play around with our negative exponents a little bit, like leading into that a little bit. So after we get through 14, 15, 16 down below, this might make a little bit more sense. But you could write your answer as negative w over 3x squared or negative 1w over 3x squared. All right, number 11, moving on here. If I have the power of a quotient. Okay, if we have the power of a quotient, again, I'm going to raise just everything inside. It's like our other property to that power. Okay, just because it's dividing instead of multiplying doesn't matter. I need to raise x to the fourth to the third power. I need to raise y squared to the third power. Now that I'm doing power per power, you can multiply. Okay, 4 times 3 is 12, 2 times 3 is 6. And there's our answer. Okay, the bases stay the same. If things start getting crazy on the inside, again, I'm going to say follow order of operations. And you're going to be better off if you simplify to begin with. 4 over 12 simplifies to 1/3. M over n, I can't simplify those. So those are going to stay the same. But I want to simplify on the inside to begin with. Then I'm going to raise everything inside to the fourth power. 1 to the fourth is 1. M squared to the fourth, power per power I'm going to multiply, is m to the 8th. 3 to the fourth power is 81. And then n to the 5th to the fourth, power per power, I'm going to multiply n to the 20th. Okay, you can see I'm showing a little bit less work as we add more and more things. And again, we're going to be okay with that. If you ever get confused, though, show your work, show your work, show your work. All right, next one I'm going to kind of, you can stop if you want and pause the video for a second and do this problem on your own. Follow order of operations, but I'll have the answer posted here in just a hot sec. Okay, here's kind of what your work should have looked like. You want to, again, start inside your parentheses. And so I would start by squaring all the stuff on the bottom. Okay? Once I've squared everything on the bottom, then I want to reduce. Stay inside these parentheses, and I'm going to want to reduce all of that. See, I make it a nice, neater little bit. And then once it's reduced, then I can square everything on the inside, and I'm going to end up with 9b squared, 64a to the 10th. You really want to work in steps like that if you don't follow order of operations. You could theoretically still get the right answer as long as you follow the right steps, but it's going to get way worse and a much uglier problem. Okay, moving on to negative exponents. Okay, when you have a negative exponent, all that tells you to do is put it on the other side of the fraction bar. Okay, it's not happy where it's at. So if it's on top, really put anything over 1. If it's on top and unhappy, you move it to the bottom and then you make it positive. If it was on the bottom and unhappy, you would move it to the top. Okay, so if I've got 2 to the negative third, this is the same thing as 1 over 2 to the third. I just need to move it to the bottom. Okay, 3 to the 5th times 3 to the negative 9th. On a problem like this, the bases are the same, so I might multiply them together first. And when I multiply, I add exponents. So this becomes 3 to the negative 4th. Then because I have a negative exponent, I never want that in my answer, so I am then going to go ahead and put it on the bottom, 1 over 3 to the 4th. And again, like we said, if you have a negative exponent on the bottom, just send that thing to the top instead, and that's how that's going to work. All right, we got 3 more problems here, reviewing kind of what we talked about, and the zero property, when I raise up power to 0, which I'll talk about in a second. But I'm going to kind of write these up, and we'll talk about them, but go ahead and give them a shot on your own as well. Okay, check your answers here. On the first one, we're multiplying these things together. So again, if I'm multiplying, I'm going to add exponents. When I add my exponents, I get a to the third, b to the negative first. Because that exponent is negative, I've got to send it to the bottom. No negative answers in your, no negative exponents in your answer. On the next one, I treated my coefficients like a fraction, and I reduced. I subtract exponents. Because I got a negative answer, that means for me to put it on the bottom, I'm going to make it positive. And then same with x's and